back to Drew Bailey.
Was it f prime of x?
Yeah.
And what did it give you? Does anybody have it written down?
7x to the 4 sevenths.
7x to the 4 sevenths. Let f prime of x equals 7x to the 4 sevenths. And which of the following, I forget the wording, but which of the following would, could not be the derivative or something like that. So A, Gabby, do you have the rest of them in front of you?
I don't.
A was f of x equal, anybody have it in front of it?
49 over 11x.
Thank you. 49 elevenths, right?
X to the 11 over 7.
Is x the next to it?
Yeah.
X to the what?
11 over 7
11 sevenths.
plus 15 over 11.
15 elevenths. Okay, so if I'm doing this and I'm checking A, I'm thinking this is f, I'm comparing it to f prime. I better take the derivative of this and see if I get that. So f prime of x, the appropriate rule is the power rule. I have 49 elevenths. This power comes down and multiplies. And then I subtract 1 from the exponent. I have to subtract 7 sevenths. 11 sevenths minus 7 sevenths is 4 sevenths plus 0. Okay. 49 sevenths is 7. Seven x to the 4 sevenths. Did that match? Yes. And did the problem say which cannot be, you said? Okay. So that one matches. I would not list that one as which one cannot be, obviously, right? All right, B. Aaron, do you have that one written down?
Yeah. That was f double prime of x equals 4x to the negative 3 sevenths.
Okay, so for this one, I'm using f prime that I know is true. I'm taking the derivative of it to see if what they gave me is the same. So I take f prime. I take 4 sevenths times, the exponent comes down, 7 x to the, subtract 1 from the exponent, subtract 7 sevenths. I have my to the negative 3 sevenths now. 7 times 4 sevenths is 4. 4x to the negative 3 sevenths is, well, obviously that's the same. That one is also the same. I would not list that as which one cannot be. All right, C.
F double prime of x equals 4 divided by the 7th root of x to the 3rd.
Okay. What's another way I could write the 7th root of x to the 3rd? X cubed to the 1/7. Everybody okay with that? Be honest, yes? If I say square root, you write to the 1/2 power. You're fine with that. 7th root, it's the 1/7, right? 5th root to the 1/5. Okay, power to a power u, multiply. So this is 4 over x to the 3 sevenths. And I'm comparing second derivative to second derivative. Is that the same as that? Yeah. They've all matched up so far. All right, D. Triple prime? What was that one?
Is negative 12 divided by 7x to the 10 over 7.
Okay, so for that one, I'm taking the second derivative that I knew worked. So I have a choice. I can take this guy in purple, or I can take this guy in green. I'm going to take the derivative of that to get the third derivative. I'd prefer to take the green one because it's a power rule. So for that one, I'm taking f triple prime of x of this guy, power rule, 4 times negative 3 sevenths x to the negative 10 sevenths. That's okay. What has the negative exponent? I think some of you are still struggling with this. Do the numbers out front have a negative exponent, or is it just the x, or is it both? Just x. So the only thing that drops or changes denominator to numerator or vice versa is the x and its exponent. So this negative 12 sevenths out front, it's staying. The x to the negative 10 sevenths was in the numerator. Now it's in the denominator. We have to ask ourselves, is that the same as I did the work on what I knew was the right second derivative? I'm comparing it to what they gave me. That is the same. Was there a letter E? It was letter E.
Letter is the answer.
Right, but what was letter E?
F triple prime of x it equals 12 over 7, and then x outside of that. Yep. X to the negative 10 7.
All right, and I'm back to what I know is true. And this one has a positive 12 sevenths. That one, the correct one is negative 12 sevenths. This could drop down, but it's still not going to have the right sign. It's positive where it should be negative. So that one is the cannot be true, which is the one we want. All right. Keep them coming. What else do you want to talk about? Nick?
Can we do 13?
Yeah, which one was 13, Nick?
It's find dy dx when y equals sine x to the x.
Like that?
Yeah.
Yep. Do you know a rule for that?
Yeah, don't you natural log both sides?
Yeah, the logarithmic
Yeah.
differentiation process.
Yeah.
Is that correct? Good so far? You should see the same. Listen, I kind of warned you guys, and most of you did really well on the quiz. I'm going to pass this back a little bit. Most of you did well on this problem. The mistakes that were made, like some people forgot the product rule. And remember on the board how we read out the steps? Every one of them is going to have a product rule, right? Why? Because the property of ln, well, of a log, specifically a natural log, is when you have it and there's an exponent, the exponent can come down front and multiply. Then you take the derivative. You're going to have a product rule. Don't forget the product rule, all right? So derivative of ln y is 1 over y dy dx. Derivative of this side is first times the derivative of the second. That's ln of u. It's 1 over u times du dx. So first times the derivative of the second plus the second times the derivative of the first. I would take a minute just to be careful and clean that up a bit. What's cosine of x over sine of x? Cotangent of x. So x cotangent x plus ln of sine of x. Multiply by y every time. And it's y times the whole thing. And the last step is to plug in what y was equal to. Y was equal to sine of x to the x. So we get sine of x to the x times x cotangent x plus ln of sine of x. I know you haven't got your quizzes back, but something I want to address, and I'll say it again when you have your quizzes. Do I need parentheses around this sine of x? No. On the quiz. think it was to the ln x, wasn't it?
Yeah, well, so I just kind of set it up.
Do I need parentheses on that?
Beats me. Whatever happened. It's in the past now. Interesting.
What's this right here? Negative 49. Order of operations, exponents, 7 squared, 49. Negative. Negative 1 times 49. 49. It is what you see. Negative 3 times x squared. 9x squared. Right? Back to the story. Parentheses? No parentheses. In the original problem, it was find the original problem is written like that. Bless you. I guess the question is, are these different or the same? They're different. Okay. This one, order of operations, you would plug in x into ln first. You would raise x to that numerical power, and then you multiply by 3. This one, you'd plug in x into the ln first. You'd plug in x into the parentheses there. That one really doesn't matter, I guess. Please excuse me. It doesn't matter. You could do it in this one first, too, as well. Doesn't matter. 3 times that, and then raise that to the exponent, right? It's different. You have to be careful. I didn't mark off this time on the quiz. All right, I did not mark off. I put it there for you, parentheses around it, in the final answer. How is that different than this then? Well, sine of x, it's not 2 terms. It's sine of x. It's 1 term, right? To the x power. The parentheses wouldn't really do anything to it, right? Here, it does. So be careful. Nick, good. Got that one?
So I always forget to substitute the y back in here. Why is it appropriate to substitute the y back in here, not like other questions you leave the y in it?
Right. What do you guys say?
Like the rate you leave the y in it.
What's the difference? On which version?
For that one, but when you plug the x back in there, you can like see it better. I guess.
You could graph it if you wanted to.
Yeah.
Just wanted to.
Right?
The y is not defined in the other ones. Like explicit.
Are there some functions or relations you cannot solve for y?
Yeah.
Yes. Take the derivative. Okay. Product rule, dy dx minus dy dx, 0, 3y squared dy dx, 0. Solve for dy dx. It's going to have y's in it. Why? Because I can't. The one time I wasn't planning on it, it's left. Maybe I shouldn't try so hard. Okay. Can't solve for y in this one. Can't solve for y, then you can't plug y as a function of x into the final answer to have it with x's in it. But what about this problem? They told you what y was equal to start with. So it's a function of x. So why would you leave your answer with y's in it if you know what y is? Does it make sense? There's a difference. One, I can write it as a function of x. One, I couldn't. Good questions today. Others from the review. right, ready to get your quizzes? We'll go over those. We'll talk about the format of the test. Ready to go.
We're not having our meetings again.
It's also not.
Here's my nice 4 out of 10 that I did on my one.
Yeah, these are not Canvas. I scrambled to grade them to get it back to you guys today.
I mean, I see
you
you had three goals on Tuesday. He does it to himself every time. He puts all the sum and stuff on one day.
Are we doing like a calculator on the one day and then a calculator on the
Yeah.
other day? Or can you move on if you finish the one in a day?
No, they're two separate parts.
Okay.
Yeah, that's kind of.
Don't remember when Dina has like 3-day long tests.
I just realized I'm getting back at like 1 a.m.
Why? Are you
Come back to the
are you going to?
And I'm also gonna go watch that.
Fancy. That's the worst, Emily. When you only miss 2 points.
I don't know.
Or is it because
You did.
the negative?
U squared minus 1 over what? Z minus
It's
U squared.
factor
And
them
it's
out of
switch those.
those terms.
So then there's automatic minus 3 points like that. Plus then also cosine I didn't put
Which would change everything.
I wrote out the rule right here on the
You can't
side.
just change two.
Yeah.
For one. I literally wrote that out and never squared it. That's tough. That's tough, wasn't it? Yeah.
This one.
That's so tough. So tough. Yeah, imagine if I memorized my formula. Also, I assume Boston, because you know the way you get some. It's doing the same thing. Because then you're guaranteeing yourself. I'm not like so upset where it's like.
That it would be, I would just like.
I was just waiting.
That's what I was at. Same here. Same here. For
No other reason, just that.
We get theirs back. Number 1 should have been cosine x minus y over x minus 2y. Or if all of your signs were different, that's fine as well. Number 2, the tangent slope is 2/11. So the derivative was what? 2x minus 2 over 3y squared minus 1. Plug in x equals 2. Get a slope of 2/11. So your tangent line should have been y minus 2 equals 2/11 times x minus 2. Number 3, negative 2x over the square root of 1 minus x to the 4th. Number 4, depends how far you went. There's a couple possible answers there. The laziest answer is 3 over absolute value of 3x times the square root of 3x squared minus 1. The next laziest answer is 3x over the absolute value of 3x times the square root of 9x squared minus 1. Then there was 1 over x radical 9x squared minus 1.
Oh my god, we're the top dogs at one.
Those are all, by lazy, I'm just, I hope you know I'm joking. Okay? It's the correct answer, and it's one of those that I can read your mind.
I like that.
Got it? It's good enough. Just write it down and be done. Let's move on.
Like, you know, the freeze cancel, I just didn't pick the after.
All right, quick little. By the way, this doesn't happen all the time. The only reason you could have dropped those absolute values on this one is because in the problem I put comma x is greater than 0. All right, and I put that there just so people who wanted to keep going.
Why would people go
Nerds.
That's the unsafe option. You
I
make an
know.
algebra mistake. Just leave it the simplified form.
All right, we need to talk about exponent rules. Okay. There's power when it comes to exponent rules. Okay. There's power. You guys need to remember. Listen, I know you learn the rules and then you kind of forget them. All right. Especially when they get ugly with like e to powers. We'll talk about that on the back page. All right. 3x squared. Obviously, you should know when you square something, it's times itself. And because multiplication is commutative, you have 3 times x. That is 9x squared. Okay? Easy. Don't make the mistake, though. 9x squared. But what about e?
Oh.
Yeah, you guys are finding out. When I record, it gets very glitchy. You guys haven't experienced that very much.
I forgot you recorded.
E to the 3x squared. That's saying e to the 3x times e to the 3x. Yes? Same bases. You multiply the bases, you do what with our exponents? Add. E to the 6x. Yes? Why am I doing this? Well, some of you forget the rules. Like, oh, e to the 3x squared. Is that e to the 6x? Is it e to the 9x squared? Go back to what it is. Go back to its essence. All right? It's multiply the bases, add their exponents. Okay? It's e to the 6x. Or power to a power you multiply. That's fine too. Good? All right, that's the front. To the back. Number 5, you should have had negative tangent of x over ln 2. Number 6, 3e to the 3x over 1 plus e to the 6x. Okay? Here's what I saw on this one. I need to address it. I do not want you to keep making this mistake. The rule was 1 over 1 plus u squared times du dx, and it was 3e to the 3x. Okay? I saw this way more than I wanted to. Not right. Why? Why is it not correct? You're adding on the bottom. You can only cancel if you have what? Multiplication. Okay, so we've done this before. This is a different problem, by the way. I'm going to do this a couple different ways, all right? Legal or illegal? I think it's kind of up in the air. I hear some people saying no, some people saying yes. It's up in the air right now, right?
You're subtracting on the bottom.
Okay. What you would have to do, if you want to make sure it's going to work, is factor out an e to the 3x, right? And I know I can factor out a 3, but do you agree that's what's left? Now I think everybody's comfortable with that. That's right. So why was that okay? Well, they both had a factor. Yeah, this is a shortcut. Technically, you should pull it out front, factor it out, to be confident that the common factors cancel. All right. All right, we're running short on time. 7. Oh, by the way, this is not right up here. This is not right. I shouldn't have put a check mark there. I'm talking about this step is not right. You cannot cancel part if it's being added. Okay? 7 is tangent of x. 8 is 7 times ln 3 times 3 to the 7x. 9 in parentheses.